Imagine a predator, just enormous, outweighing even a champion St. Bernard dog. A creature sort of shrouded in myth, really, until science finally started to pull back the layers.
And when they did,
Mm.
wow, everything we thought we knew, and especially about its main weapon, completely wrong.
So today we're diving deep into the Komodo dragon, the world's largest living lizard, Varanus komodoensis.
Yeah, and our mission, you could say, is to unpack how science totally flipped the script on this thing, moving it from this sort of biological myth to a genuinely terrifying, sophisticated reality.
Okay, let's get a sense of the scale first, because you really need to picture this. It's not just a big lizard.
No is the undisputed heavyweight champ. Out of, what, over 80 species of monitor lizards, this is the top.
Right, and compared to something familiar, maybe like a big green iguana.
Good comparison. An iguana might hit, say, 1.5 meters, maybe 8 kilos. Pretty heavy for a pet.
Uh-huh.
But the biggest Komodos, they can easily double that length. And the weight, we're talking potentially over 160 kilos more.
That figure, 166 kilos for the largest recorded one, it's staggering. And the comparison used is just perfect.
Which one? The St. Bernard.
Yeah. That 166 kilos is heavier than the biggest recorded St. Bernard Benedictine at 162 kilos.
And just picture that contrast for a second. You've got this gentle giant dog bred to rescue people.
Right.
And then this reptile, heavier, covered in armored skin, claws, a mouth built for, well, not rescue.
Definitely not rescue. Built for destruction.
Yeah.
Armed and dangerous. And the big mystery was always how it was so dangerous.
Exactly, because for, gosh, over 100 years, the idea was all about filth.
The dirty mouth theory. That it didn't kill quickly, it just bit you, loaded you with horrible bacteria.
Yeah, septic bacteria. The idea was it would track the prey for days, just waiting for the infection to do the job.
Yeah.
Biological warfare, but, slow and disgusting.
A boatload of festering microbes, as one source put it. Grim.
Totally grim. But here's where modern research just threw that whole idea out.
Professor Brian Fry and others, they actually looked at the bacteria in their mouths, didn't they?
They did. And guess what? The old theory. Officially debunked. Completely false.
So what did they find? Their mouths aren't festering pits.
Get this. They're actually cleaner than the average human mouth. Especially the adults, who clean their mouths pretty thoroughly after eating.
Cleaner than ours. That's hard to believe considering they eat rotting carcasses. How?
Well, the saliva flow, the tongue cleaning.
Yeah.
But the real kicker wasn't there, it was what was. They weren't using bacteria, they were using venom.
Venom. Like a snake?
Well, like other venomous lizards, they found the exact same kind of venom glands you see in, say, a Gila monster or a Mexican beaded lizard, right there in the lower jaw.
Okay, hold on. So it's not bacteria, it's venom. What kind of venom? What does it do?
It produces this cocktail, and the main component acts as a really powerful anticoagulant.
Anticoagulant, so stopping blood clotting.
Exactly, the opposite of clotting. So when the dragon bites, the venom gets into the wound and basically prevents it from sealing up. It causes a massive drop in blood pressure, shock.
So instead of a slow infection over days.
It's rapid, persistent, massive bleeding, systemic shock. It's immediate biological warfare, much more sophisticated. But interestingly, the venom isn't even the star of the show. It's more like a crucial supporting actor.
Supporting the teeth, right? Because the bite itself is something else.
Oh, yeah. It's fascinating. They don't have that bone-crushing bite force like a crocodile.
Right. I read that.
Instead, it's all about the slicing. Long, curved teeth, deeply serrated like steak knives.
And the venom makes those teeth even deadlier, like a poison-tipped blade was the phrase.
Perfect description. They'd bite. They'd use those incredibly powerful neck muscles to just thrash their head, ripping huge chunks of flesh. The teeth are designed purely for that catastrophic cutting.
But there's another layer to the teeth, isn't there? Something about the structure itself. Dr. Aaron LeBlanc's work.
Yes. This is really cool. He found that the enamel on their teeth, the hard protective layer we have, on a Komodo, it's paper thin. Just a tiny fraction of the thickness of human enamel.
Which seems counterintuitive, right? For ripping through tough hide and meat, you'd think they'd need super thick enamel.
You would. It puzzled researchers. Why evolve such seemingly fragile teeth? But the answer wasn't in the thickness, it was in the minerals.
Minerals? Like what?
Iron. He discovered that the cutting edge, the sharp serrated part, is coated in this concentrated layer of iron. It's so rich it actually makes the edges look visibly orange.
Wow. An iron coating. Like they're biologically forged. Does anything else do that?
Beavers do something similar, incorporating iron into their enamel structure to make the whole tooth tougher.
Okay.
But the Komodo's different. It's an external coating rich in iron but poor in calcium. super thin, like 11,000th of a millimeter. Someone called it icing on a cake.
That's incredible, like a disposable, self-sharpening scalpel edge.
Exactly. It maintains that razor sharpness despite the thin underlying structure. It's constantly honed.
So you put it all together, these iron-edged, serrated blades delivering an anticoagulant venom. What does that translate to in terms of hunting success?
It pushes them into super predator territory. The stats are pretty amazing. The teeth alone, just the physical damage and blood loss, that accounts for maybe 60–70% of prey bleeding out within, like, 10 to 15 minutes.
Which is already incredibly effective.
Highly effective. But then you add the venom's effect.
The anticoagulant keeping the wounds open.
Right. That adds another critical 20–25% success. It ensures that even if the animal initially gets away, the bleeding is prolonged, persistent over the next 3 or 4 hours.
So the total success rate comes out to?
Somewhere between 90 and 95%.
Yeah.
Which is just phenomenal.
That's higher than an African lion, right? Higher than a great white shark.
Significantly higher. It puts them right at the top tier of predatory efficiency, especially considering they often tackle prey much, much larger than themselves, like water buffalo.
Amazing. But that success relies on finding the prey, especially if it stumbles off after the bite.
Absolutely. If that buffalo drops dead 4 kilometers away, the Komodo needs to find it. And that's where another incredible sense comes in.
Their sense of smell? Which isn't just about the nostrils.
No, it's all about that iconic forked tongue, flicking in and out, constantly sampling the air.
Tasting the air, essentially.
Pretty much. It picks up airborne scent molecules and delivers them up to special organs on the roof of the mouth. The Jacobson's organs, or vomeronasal organs.
And the fork lets them know the direction, yeah.
Precisely. If the left fork picks up slightly more molecules of, say, rotting carcass than the right fork,
it knows the scent is coming from the left.
Exactly. It gives them this incredible directional precision, guiding them through the landscape. Humans have those organs too, technically, but they're likely vestigial, non-functional for us.
Not for the Komodo. It's vital for finding food, dead or alive.
And for finding mates too, as we'll see. But yeah, once they locate a potential meal, they are famously unfussy.
Probably the least picky eaters on the planet. The descriptions are wild rodents, deer, water buffalo, even carrion, bones, hooves, hide, everything.
The whole lot. And yeah, unfortunately, they aren't above cannibalism either. Smaller Komodos are definitely on the menu for larger adults.
And they're primarily stealth hunters, wading along game trails.
That's their main strategy. They can manage short bursts of speed, but they prefer to ambush, lying in wait for hours sometimes.
And when they do eat, the volume is legendary.
Truly staggering. They can consume up to 80% of their own body weight in a single sitting.
80%. How?
Strong throat muscles and incredibly flexible jaws that hinge wide open. They basically just gulp down huge chunks, sometimes whole limbs.
And that one massive meal can sustain them for how long?
Upwards of a month, maybe even longer. It means they might only need to make a successful kill about 12 times a year. Talk about efficiency.
That whole system is just incredibly efficient. But their life cycle, their reproduction, that's got some equally fascinating, maybe even bizarre twists.
Oh, absolutely. Finding a mate involves that Jacobson's organ again. Females leave scent trails in their droppings to signal readiness.
And if multiple males show up?
Then it's fight night. Brutal wrestling matches, upright, grappling. Quite a spectacle.
But here's a key detail. They might get battered, but the venom isn't a factor in those fights, is it?
Correct. Komodos are immune to their own venom and the venom of other Komodos. So the loser might limp away, but they won't succumb to a venomous bite from the winner.
Okay, but then there's the other way they reproduce, without a male at all. Parthenogenesis.
Yes, the virgin birth capability.
Yeah.
It's quite astonishing. Females can basically fertilize their own eggs.
How does that work biologically? It seems to break the rules.
Well, they're born carrying both male and female chromosomes. This genetic makeup allows a female, under certain circumstances, usually when no males are available, to trigger development in her eggs without sperm.
But it's not cloning, right? There's a catch.
A big catch. These parthenogenic clutches only ever produce male offspring. ZZ chromosomes, essentially doubling the female's Z chromosome.
Which, in small, isolated island populations, that has to raise concerns about inbreeding and lack of genetic diversity down the line.
Big concerns, yeah. It's a survival mechanism, but maybe not a long-term solution. And once those hatchlings emerge, male or female, their first big challenges.
Avoiding being eaten by the adults. Cannibalism again.
It's a huge risk.
Yeah.
So the babies have instincts to survive. First thing they do, head for the trees. They spend most of their first year or so arboreal, up in the branches where the heavy adults can't easily reach them.
Smart move. But what if they have to come down to the ground?
Then they employ a rather pungent defense mechanism. They roll around in feces, their own or whatever they can find.
Seriously, they cover themselves in poop.
Yep. The idea is to make themselves smell so utterly disgusting that even a hungry adult Komodo thinks twice. A sort of anti-cannibalism perfume from hell.
Whatever works, I guess. It paints a picture of a tough life right from the start. And looking at the Komodo today, it's like looking at a living piece of history, isn't it? A link to giants.
Absolutely. They are the closest living relative to an even bigger extinct monitor lizard, Megalania.
And Megalania was just immense.
Colossal. We're talking potentially up to 7 meters long, weighing maybe 2,000 kilos, the size of a small bus.
Yeah.
Imagine that patrolling the landscape.
Truly terrifying. And the timeline is fascinating, too. Komodos didn't evolve on Komodo Island, did they?
No, they evolved in Australia. The oldest fossils are around 3.5 million years old, found in Queensland. They only migrated out to the Indonesian islands about 1 million years ago.
Which means they lived alongside Megalania in Australia for a long time.
They were contemporaries, 2 giant lizards sharing the same ecosystem.
So what happened to the bigger one? Why did Megalania disappear?
Well, it vanished around 40,000 years ago.
Huh.
For a long time, people thought maybe climate change.
But the evidence points elsewhere now.
Overwhelmingly, it points to the arrival of humans in Australia. The timing fits perfectly.
The classic megafauna extinction pattern, overhunting, maybe targeting the slower juveniles, plus habitat changes from human set fires.
Exactly. And that provides a really chilling, direct lesson for today. Because the threats that likely wiped out Megalania 40,000 years ago,
they're the same threats facing the Komodo dragon right now. Habitat loss, human encroachment.
precisely, they're endangered, clinging on in just a few protected areas. Outside those parks, they're losing ground to human populations. It's the same story, just 40,000 years later.
It's quite a journey of understanding, isn't it? From European scientists first formally describing it in 1910, mislabeling its weapon for decades.
Yeah, giving it that dramatic dragon name in 1927, thinking it killed with filth.
Only to finally realize, relatively recently, that it's this incredibly sophisticated predator with ironclad teeth and potent venom.
And now that we truly understand how formidable and unique it is, we also have to grasp its vulnerability. There are only about 2,500 left in the wild.
So maybe we should be afraid for them, not just of them.
I think that's exactly right. Conservation groups like the Komodo Survival Program, the Taronga Conservation Society, their work is critical. This animal is the last remnant of this giant lizard lineage.
So, here's a thought to leave you with. If the evidence strongly suggests that human activity drove their massive cousin, Megalania, to extinction tens of thousands of years ago, what's our responsibility now? Knowing what we know about history, about conservation, how do we make sure the Komodo dragon doesn't end up as just another fossil record, something to think about?